When dealing with bivariate data, you should always start by plotting a scatter diagram. One reason for doing this is that it helps you spot rogue data. If we look at this diagram, we can see all of our data lines up very well along a straight line. Whereas on this diagram, one piece stands out. This could potentially be a piece of rogue data, and the collection of this data could then be investigated. A second reason for doing this is that it can help us decide whether or not we should be calculating the product moment correlation coefficient to investigate the relationship. If we look at this graph, the points do arrange themselves reasonably along a straight line. Therefore, we could infer that there is a linear relationship here, and then it's appropriate to calculate the PMCC, as this does investigate how well the data fits to a straight line. With this data, however, we can see that there is a relationship, but this relationship is not linear. Therefore, the product moment correlation coefficient is not appropriate. Finally, analyzing exactly what significance a value of R has is beyond the scope of this discussion, except that we could say that if R is close to 1, then the data is very strongly positively correlated. If it's close to -1, then it's clearly very strongly negatively correlated. If R is close to 0, we can say that there is no linear correlation. At this stage, however, it's difficult to say things about R is 0.7 and R is 0.4 without knowing considerably more about the actual data. Many people say 0.7 is a moderate correlation. Something closer to 0.9 would be a strong correlation, and 0.4 a weak correlation. Anything beyond these sorts of statements is beyond the scope of S1.